Assalamualaikum and good morning. My name is Nurshameela Ayuni Binti Muhammad Shafie and my partner is Jathryz Jurin. Today we are going to present about non-destructive testing and more to the liquid penetrate testing.
Non-destructive testing, or NDT, is like a secret detective for things. It checks and studies materials, parts, and structures without hurting them. NDT aims to find any problems, faults, or strange things in what's being checked. This means it helps them to make sure the thing is strong, safe, and trustworthy. NDT came about because we needed ways to study things without breaking them. Before, we had to destroy samples to learn about them. But that wasn't good for things that needed to stay whole or in use. NDT's history goes way back to different science and engineering steps. But one pioneer, A. Griffith, looked at how cracks work in materials. His ideas helped create NDT methods, along with other engineers who later on chipped in with their ideas. During World War II, NDT grew big. Planes needed checks without breaking them. This made NDT more important, and methods like seeing things inside, which now we call radiography, and using sound or ultrasonic testing, got better. NDT isn't tied to one place. Many people from different countries help make it. Now, NDT is used in lots of industries like making things, buildings, flying planes, driving cars, and more. It helps make sure things are in good quality and safe by finding hidden issues. So, NDT is like a smart inspector that keeps things strong and safe without breaking them. This report is all about non-destructive testing, or NDT. We want to explain what NDT is, how it works, and where it's used. NDT is super important because it helps keep things safe and strong. We'll show how NDT is better than breaking things to test them. We'll also share real stories of how NDT helps in different jobs like making stuff, flying planes, and more. NDT helps avoid problems, save money, and make things work better. We'll also talk about new ways NDT is getting even cooler. This report is for people who want to understand NDT and how it helps in different industries.
Liquid penetrate testing LPT is a non-destructive testing, which is that also known as dye penetrate testing. The reason for its develop is to use to inspect and detect the problem such as crack on the spot and portable. LPT was existed in early 19th century that introduced by Sir John Isaac Thornycroft, which is British engineer. The concept of liquid penetrate testing involved in few steps such as pre-cleaning, penetrate application, removal of penetrant, develop application, inspection, and do the post cleaning.
Non-destructive testing is like giving something a thorough checkup without causing any harm. It's about using clever method to find any hidden problems in things like materials, or products. One method is called the liquid penetrant testing, or LPT. It's like applying a special liquid to something and letting it soak in. Then, we use another substance to bring out the liquid and any flaws it found. This way, we can see if there are any tiny cracks or issues on the surface that might not be easy to spot with our eyes alone.
Liquid penetrate testing of non-destructive testing is a process that used to reveal the surface disconnecting by blowout of a colored visible and fluorescent dye from the detect area, as long as the defects are open to the surface and are. As a result, it is frequently used on a several machine parts, welded manufactured goods, and so on. LPT is used in the large industry because it is low-cost method. Metal such as aluminum, steel, titanium, copper, and so on. Such as example, Alenia Aeronautic Company was used liquid penetrate testing to identify, localize, and evaluation the disconnecting and all kind of flaws, verify the consistency and characteristic and composition of the materials and parts, measuring the part geometrical properties. LPT is used frequently more than eddy current testing because it is shorter time in the total process. There are few types of industries that use LPT to detect crack, which are aerospace, automotive, manufacturing, power generation, marine, railway, and construction field. There are various types of non-destructive testing used for ensuring the material used in factory safe and sound without having cracks. Liquid penetrate testing suitable for surface inspection of mass manufactured product in manufacturing field. It is because LPT is limited to surface of anomalies and many variables can affect the result of the inspection. Next, LPT was used widely in automotive field to detect defects on the component of the automotive parts such as car. Last but not least, LPT play a constructive role in the final acceptance of aerospace component during manufacturing inspection and during MBO, maintenance, repair, and overhaul. Inspections are carried out to validate the components for further service and to remove the defective component and prevent service failure. How is liquid penetrate testing? Firstly, pre-cleaning process was the first step in liquid penetrate testing. The surface that we want to examine should be clean, dried, and devoid of any debris that can obstruct surface aperture, such as lint, greases, welding flux, welding spatter, oil, or other foreign substance. Next, the penetrant liquid is applied on the surface where it's open or on discontinuities or fissures. Then it dwell for a set amount of time. By using capillary action, the penetrant penetrates through any surface flaws if the component is tiny enough. It can be dipped into a tank of penetrant. After applying penetrant on the inspection surface material, the excess liquid was removed carefully so that basically only the discontinuities that are exposed to the surface are left for the liquid to remain in. After removing the excess penetrant, a white clock-like developer was applied to entire surface, which is typically made of some sort of porous material, such as an absorbent coating. The purpose of the developer application is to prevent visual scrutiny of the penetrating tracks into the discontinuity. There are two types of developer, which are dry and wet. Dry developer is a powder that can be applied to a part of dipping it in a chamber, a hand powder bowl, a tower cannon, or a dust storming chamber after the part has been dried with warm air or hot air circulation. While the wet developer, the drying time can be speed up by using warm air or by keeping the developer in a hot air oven. According to the process, during the inspection process occur, inspector will conduct this process by using visual examination. When using fluorescent penetrate, it is necessary to use a high intensity UV lamp or black light to observe signal in low light to ensure the defect glow and more apparent, while using the visible dye testing only need white light. Not least, after done with all the previous process, we need to do the post-cleaning process. For the LPT method, to produce accurate and dependable finding, proper post-cleaning is crucial. There are various post-cleaning techniques, and the strategy depend on the penetrant type and the test criteria. The post-cleaning produce goal is to eliminate any remaining penetrant from the surface, leaving only the penetrant that has been trapped in surface flaws, increasing the visibility of the indicator during examination. Post-cleaning process conducted using different methods because it depends on the type of penetrant using and the test requirement.
Making sure liquid penetrant testing, or LPT, works well depends on a few things. You need a clean surface for the liquid to work its magic. Picking the right liquid is also important based on what you're testing. The time the liquid stays on the surface matters too. It decides how deep it goes. Applying something to bring out the liquid from defects helps us see them. Also, if the surface is too hot or cold, it can change how the liquid works.
In methodology, we are depth into the liquid penetrate testing and explore several industries that use liquid penetrate testing materials and the differentiation between experimental setup theoretically and expected outcome. Last but not least, conclusion was included in this methodology.
When we do LPT, we need a few things. 1. Penetrate. 2. Developer. 3. Cleaner. 4. Emulsify. 5. UV lamp. 6. Brushes and cloths. 7. Inspection equipment. Remember, the things we use can change depending on the test we're doing. It's important to use them the right way to get the best results. Setting up a test to use LPT in NDT needs careful planning. Here's how. 1. Start with a goal. Know what you want to find with LPT. It could be finding problems, checking how well LPT works, or comparing different things. 2. Pick test samples. Choose things to test that match what you're interested in. Think about their size, shape, and any issues that they might have. 3. Get ready. Make sure the test samples are super clean so the test is accurate. 4. Choose LPT details. Decide if you're using the dye or any kind of other liquids. And also know how long the liquid stays. How long the liquid stays on, and it will depend how long you use the developer. 5. Set up the test. Have a good spot for the test and think about any good lights or special equipment needed so that you can put on the developer and the liquid easily. 6. Do the test. Put on the liquid, wait, and then use the developer. See what happens and write it down. 7. Think about theory. Understand the science behind LPT. Think about things like how the liquid moves and how defects shows up. 8. Collect the data. Write down everything that you saw that happened during the test and what it means. 9. Understand and check. Think about what you found. Does it match with the science that you know? Is the LPT working well? 10. Make conclusions. Sum up what you found and what it means. Think about any issues you face and what LPT did well. 11. Give advice. If you found ways to do LPT better, share them. Help others learn from your tests. These following were steps to help you set up a good test with liquid penetrate testing. Remember, details matter in NDT tests to get good and trustworthy results.
Expected outcome for this inspection is to locate and characterize surface flaw or discontinuities that could compromise a material structure integrity, functionality, or safety. In order to get good defects visibility, there are two types of penetrates, which are fluorescence penetrate and visible penetrate. By using fluorescent penetrate, visible indication appear on the surface of material that's being inspected. When the fluorescence penetrate seep into and become stuck into the surface, breaking flaws including crack, porosity, laps, seams, and other sorts of discontinuities, and the sign become visible. Next, similar to fluorescent penetrate, a color liquid penetrate, usually red or fluorescent green, is applied to the surface of the material to be inspected after it has been thoroughly cleaned to remove any contaminants, oil, or dirt that could be obstruct the inspection process of the visible penetrate. Any surface breaking flaws are given the opportunity to be penetrated by the penetrant through capillary action. Overall, the expected outcome depends on the penetrate used, which are fluorescence or visible penetrate, the position of the cracks, or other criteria such as the particular application, material types, and inspection needs might influence the choice of the penetrate, whether visible or fluorescent. As a conclusion, liquid penetrate testing (LPT) really play crucial parts in our industries during this revolution generation. Liquid penetrate testing effects and useful for detecting cracks. Moreover, LPT is relatively low cost and highly portable among another NDT method. LPT is highly sensitive to the cracks on the material surface and can be used on the variety of the materials. That's all. Thank you.